We're doing modeling data with quadratic functions, so 5.1. And so what we did on our video should be a bit helpful to you. All right? Just so, quadratic function. How do you know something's in a quadratic function? Yeah.
I said x squared.
Yeah, you have an x squared. Now, x squared has to be your highest degree, right? So, like if I had y equals x cubed plus x squared plus x, that's not a quadratic, okay? Even though it has that x, oops, see, I forgot the square. Even though it has that x squared, all right? If the greatest degree has to be x squared. So in this case, if I'm doing this, you have to have the greatest degree be that x squared, the highest power, which we call a degree. Get used to that term. Your highest degree is 2. Okay? Your lowest degree could be x. Could be you could have an x to the first. So we'll see that in standard form here. Standard form is y equals ax squared
plus bx
plus bx plus c
equals 0.
Equals y, which we actually plug 0 in for. Okay? So, but in standard form, y equals ax squared plus bx plus c. Graph of a quadratic is called a?
Parabola.
Parabola. Parabola. I'm finding it very difficult to erase right now because I can't find the thing that I want to erase. That's kind of weird. Never actually tried to teach it. Weird. All right. That hopefully is a review. Okay. Now let's go in. Any questions on that? Okay. Example 1 talks to you about how to multiply. Now, this is something you did a lot in algebra. Those of you here this summer, we spent a lot of time on it. But tell whether the function y equals 2x plus 3 times the quantity x minus 4 is linear or quadratic. And then begin, it says begin by rewriting the function in standard form. In order to do standard form, you'd have to multiply this out. Now this shows FOIL. Now, some of you learned FOIL. I don't usually teach FOIL. I just teach distributive property. Okay, but it works for a lot of students. So there we go. We're multiplying 2x by x to get 2x squared. I'm going to write it here. We multiply 2x by 4, or negative 4, to get negative 8x. And then, so first term by each term in the other. Okay. And then we go our 3 times each. So 3 times x is 3x. And I stack that right underneath. I make a second line because I'm multiplying by a second term. And I stack it right underneath the like terms. And then 3 times negative 4 is negative 12. We add them up. We get our 2x squared minus 5x minus 12. And there we've got it right there. Okay? That is our quadratic. Now they show it here, and I'm not, whatever you want to use. If you like FOIL and it works, that's great. The only problem I have with FOIL is when you start multiplying by cubics. So maybe, trinomials on the outside. So maybe if you have a 2x plus 5 times x minus 4, or x squared minus 4x plus 2. Now you can't use FOIL anymore, right? Because you don't have a first, outers, inners, and last. Okay, that doesn't work like that. Now you'd have to use distributive property. Okay, and then like that. First term by each thing in, and second term by each other. Okay, and we'll get into some of those as well. All right, but we know this is a quadratic since x squared is our highest degree, so we're good to go there. All right, I want you to practice this. This seems to be an area where students struggle, so I want you to do A through D in your notes, please. Those 4 problems. Okay, here we go. Letter A. Letter A, we go x times x to give us x squared. X times 2 to give us 2x. Negative 3 times x gives us negative 3x. And negative 3 times 2 is negative 6. So we get y equals x squared minus x minus 6. How many got it? Very good. Okay, looking for minor mistakes. Dylan asked if we need to show work. It's a good idea on your assignment for sure to show your work, especially when you want to find out if you're making a mistake. Remember, y and f of x are the same thing. They mean the same variable. Those of you talking, you may know it, but the people around you might not. Not to mention it disrupts me and makes it tough for me to think. So x times x is x squared. X times 3 is 3x. It gives me f of x, which is same thing as what? As y. Good. F of x equals x squared plus 3x. How many got it? Okay. Next one. Actually, any questions on those two before we move past them? I'm going through. I will at the end. Yeah. Okay. All right. So let's go on. Letter C. X squared plus 5x minus x squared. In this case, I don't have to multiply anything. X squared minus x squared is 0. Notice I just dropped the parentheses since there's nothing to distribute in. F of x equals 5x. How many got it? Okay. That, by the way, should be our only linear. Everything else is going to be quadratic in these. Okay? So A and B were quads. Okay, and D is going to be a quadratic. Now let's see. This is the one where students make mistakes. How many got x squared plus 25? No, good. Man, I'm perfect then. How many got x minus 5 times x minus 5?
Yeah.
That's what that is, right? Then we got to multiply it out, right? How many got x squared minus 25? Oh, okay, so x squared minus 5x plus 25 gives us x squared minus 10x plus 25. And y equals. How many got that?
Yeah.
Hey, good job. Now, if you made the mistake, don't feel bad. A lot of people do. However, you don't want to anymore. Okay? You should automatically know when you're squaring something, you make its twin right next to it. Okay? You multiply it. Questions? Good. All right. Moving on. I would like you to now take a look at, we're going to add a section of our notes called, well, I would title it this, Finding a Quadratic Model from a Set of Data.
Can we do it on the outside?
You can put it on your notes, yeah. Turn your note page over. I'm gonna show you 3 different methods, and then I'm gonna let you go at doing your work. Okay? So we're gonna go through 3 different methods. So you can do a method A, a B, and a C. I think the book shows 2 of these methods. I'm gonna show you 3 because we're that much cooler than the book. All right? So find the quadratic model for each set of data, and you have this set of data. The first way we do it is we just look for patterns. So this is going to be the look for pattern method. Some of you can do that pretty easy. You really are asking yourself, what do you do to x to get to f of x? Okay? So what do you do to x to get f of x? Or what do you do to your input, which is your x, to get to your output, your f of x? So in this case, this one's a pretty simple one, I'd hope. I mean, you try adding plus 0. Well, it doesn't work here. You try multiplying 1 times 1. Okay, remember it's quadratic. So if I'm thinking x squared, well, x times x is 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So if I multiply x by x, I get f of x. So this is f of x equals x squared. We have now wrote our quadratic model. For those of you who are like, huh, what's a quadratic model? In other words, that's write an equation. Okay, a quadratic model is the equation. It's pretty cool when I look at it, you guys, right now because of that. It's like you're all shining. Like there's like shimmeries from everyone. It's kind of weird. Yeah, because of my it doesn't hurt. Like I don't get a headache. I just can't see clearly. And it's triggered by, like, what happened is right as you guys walked into class and I turned on the projector and I looked out there, my eyes glimpsed the light bulb there. And yeah, you guys know that light, like when you look in the light? Well, sometimes for me, that just triggers that visual migraine. So right now, everyone's got like bursts around them. I'm like, it's kind of tricky, man. It's very tough, though, for me to see different things on this screen. No, I'm not going to draw. I'm not a good drawer.
If you look into dark places, does it give you a migraine?
No. Okay. All right. Number 15. Let's go on. Next one. We're going to use quadratic regression. Now, we've studied linear regression. Now, this is not what the directions for 15 are the same as the directions for 13 on your sheet. But what I'm going to show you using 15 is quadratic regression using our calculator. So what you need, if you don't have one, is a graphing calculator. Okay, so get one of those out. And I'm going to walk you through how to put this stuff in. So you're given two lists, meaning you're going to use your list feature. This is going to be list 1 and list 2, unless you have things in those lists that you really don't want to delete. Maybe you have, like, I don't know what you'd have in there, but maybe you have something amazing that you don't want to delete. Okay, so if you recall, how do we put a list in?
What? We never did that.
Yeah, it's actually stat. It's not second stat, even though second stat does say list, which you would assume that it was that, but it's not. It's kind of weird. So we're going to click on stat. Here are your instructions. After we go to stat, no, not stat plot, stat. So that's this button right here. Okay. You would think it would be list, because that would make sense, but it's not. It's stat. Okay. All right. So we click on stat. We enter option 1, which is edit. Okay. And once we hit edit, edit brings us to this, where we put in things. Now, I've already put my lists in. List 1, I made X. List 2, I made Y, or F of X. So you're going to enter your values. Now, if you're not using list 1 and 2, then you've got to remember what you called X and what you called F of X for later. Otherwise, it's not going to work for you. Okay? Okay, a good check at the end before you clear out is to make sure you have the same number of X's as you do Y's. Or F of X, list 1 and list 2, same number of pieces of data. Okay? So once you get that, let's go ahead and hit quit. It's on your paper too, right? Number 15. I don't have any. Well, I have my list in there. Okay, if you're not done, calculators are in your hand. If you are done, they're on your desk, please. That way I know who's not done and who is done. If you have a friend that just plays Blockman all period, make them, help them out. Okay? I don't know. All right. Hannah, you got it? Put out? Okay. So from there, we're going to make sure all of our y equals are off. So I'm going to go to y equals, and I just make sure that I don't have anything in there. Or if I do, that I've got it turned off. So I don't have any equations in, but let's say I had my ultra favorite equation in right here, y equals x. And I'm like, dude, I just don't delete that. That takes too long to type. So I'm going to turn that one off by going over to the equal sign and hitting enter. And now it's off, right? Okay, so it's up to you. If there's something in there you just don't want to delete, whatever. You need to make sure your plot number 1 is turned on and all others are off. Now, there's a couple ways to do this. You could go up to plot and hit enter, and now it's turned on because it's highlighted. However, you don't know what it's set at. It's probably set at your defaults. So what I'm going to do, I'm going to do the other method. I'm going to turn it off here, and I'm going to go to second y equals, which is stat plot. Okay? So if we go to stat plot, So okay, second y equals. At that point, let's see if I can get that so you guys can see a little better. There we go. So at that point, notice these all say off. I want stat plot 1 to be on. So I'm going to click enter. I'm going to highlight on and hit enter. And notice the plot type. We could have all of these. I'm going with the scatter plot. Okay, I want my x list. Remember I said if you use different lists, I want my x values to be list 1 because up here, x is list 1. I want my y values to be list 2 because here, f of x or y is list 2. That's the default. You could choose whichever. Look, they give you options. You could have that, that, or that to be your little points. I know.
Does it matter?
No, but I'm going with that one because I don't want to go through all the work of changing it. You know, scroll down and stuff.
I'm gonna do
Yeah.
plus.
All right. So from there we hit graph,
Oh my gosh.
and that's what we get. Something amazing that looks like that.
Beautiful.
Okay. So just so that we can see everything after we hit graph, I am going to hit zoom. Let's go to zoom. I'm not going to go zoom out. I'm going to go to zoom number. Which one? I've already seen it. Yeah, zoom stat, right? Because we use stat. So zoom 9, which is stat. And when you do that, then it's really amazing. You're like, whoa.
Dude, that's incredible.
Okay. So from there, if we actually want to get the equation, because right now all we've done is we've graphed it, which they didn't even ask us to do. It's like you're wasting my time. Okay. If we want to actually get the equation, we can do what's called quadratic regression. So if you go back to stat, and after stat, I want you to arrow over, okay, to your left. So let's go stat. We'll arrow over to calc.
Wait, you said arrow to the left.
That's what I meant, to the right, my other left. Okay? Go to the right, and then go to calc, and I want, which one? Yeah, I want quadratic regression, because I'm dealing with a quadratic. How do I know? Because this is a quadratic worksheet. Now, there are times when you're going to have to figure out if it's linear, quadratic, cubic, trigonometric, okay, and that we'll figure out how closely it relates to those, and I'll show you a method to do that. But for now, we're going to go quadratic regression, option 5. Okay, so when I click on 5, then it gives me all this menu. I want to go all the way down to calculate. For some of you, you might have a bit different menu, but reality is you keep hitting enter until, because it's saying list 1, list 2, okay, you keep hitting enter until it gives you some stuff. Okay, your A, B, and C term. Okay. Okay, in this case, A equals B equals C equals, in this case, remember, a quadratic is in the form of y equals ax squared plus bx plus c. They've given us A, B, and C. A is -2, x squared, B is 0, and C is 12. Or we could just write it as y equals, don't forget your y equals, -2x squared plus 12. Okay, so now we have the graph there. Okay, or excuse me, I have the equation there. How many are with me? That's quite the process, right? This whole thing will be online, remember, if you really want to get it in your notes and you didn't get all that copied. But I believe if you go down to catalog, second 0, second 0, second 0, third time. Okay, after we get to catalog, if you go to what's called diagnostic, so notice up here when I went to second 0, it put a little A in the right hand corner. Everyone see that? That means your alpha key has been used. we haven't used it. It just automatically puts it there. Like if I push alpha, that disappears. If I push alpha again, it's like another shift key or second key. Okay? So from here, what I'm going to do, since I want to go to diagnostic on, I'm going to go alpha. It's already highlighted, and go to D. Notice the D's on matrix. Okay? Alpha D. And it brings me down to D's. And I'm going to keep scrolling there until I get to what's called diagnostic on. And I'm going to hit enter. And then I hit enter again. And then it says done. Now you're like, well, what did it do? Well, if you enter this quadratic regression again, so I'm just going to go second enter to bring back my previous entries. And I hit enter. Oops, there it is. R squared is 1. The closer R squared is to 1, the more exact the match is. Okay, so right here, this is telling me this is an exact match. This is a quadratic. Now, if I don't want you to do this. For those of you who are staying with me, if I go to if I go back to stat and I go to calculate and I do linear regression, it'll give me an equation, -4x plus 10. However, notice R squared, it's 0.7. In other words, it's saying it kind of matches up. It doesn't really match up. It means if I plotted these points, hold on one second, let me do this real quick. Okay, if I graph this there, there's my line of best fit using a linear equation. Everyone see that? It doesn't match up really well, right? We just tried to draw a line of best fit in that scatter plot. Okay, versus when I do a quadratic, you see the quadratic hits those points exactly because it's a perfect fit. That's what that R squared, that's what that diagnostic tool tells you. It may not seem like a big deal now, but it will be as you progress. So anyway, next piece. I want you guys, any questions on this?
When I do it on my calculator, when I press second enter, all it does is give me the diagnostic on it.
Yeah, that's what happened to me too.
Yeah, you got to keep hitting second enter.
That just...
Keep going. Keep going. No, you don't hit second enter. If you want to bring back a previous entry, you've got to go second enter, and it scrolls through your previous entries.
How did you?
It's still not doing it.
Just keep going. You've entered it like 5.
Oh, crap.
Keep going. It'll eventually show up.
How did you get
You can go back and watch the video. There's a step there, but I've shown you guys how to do that with linear regression earlier in the year. I don't have time to go through that right now. If you want to come back individually, I can help you. Yeah.
So, your final answer for that question would just be y equals -2x squared plus 12.
That would be it.
All right.
Okay. Did it come up, Lee?
Yeah.
Okay. Ladies and gentlemen, I want to do the last one. Here we go. Number 15 or number 14. Number 14, we're going to go through these steps to find the quadratic model using matrices this time. Okay, so now with matrices, you recall last chapter? Yes. Last chapter we were given equations with 3 variables in them. And right now, really what we're trying to find are 3 variables. If I have this standard form of y equals ax squared plus bx plus c, I want you to tell your neighbor which 3 variables you're looking for.
A, B, and C.
Good. Looking for A, B, and C. I want to know those. What do I already know? Well, I know x and y's. Okay, I have values for x and y's. I have an x here and a y here, an x here, a y here, an x here. I have 5 pairs of x, y's. Okay, if I'm looking for 3 variables, how many equations do I need?
Wait, 3?
I need 3. So what I could do, I could set up some matrices. I could say, well, I know that if I go x squared x, and, right, I'm taking the coefficient. So if I think of this in a different way, I can think of this as x squared times a. Right, I'm just moving these around. Everyone get that? Yeah. So my coefficient of a is x squared. My coefficient of b is what? X. So I'm just moving these around. It's okay to do that. What's my coefficient of c?
0. 1.
Yeah, it's actually 1, right? It's 1 times c. So I think of it like this. Okay? And that's going to equal y. Okay? And so over here I'm going to have y. So this is going to be my matrix. I need 3 equations. So if I think of it, I can go, well, okay, when y is 5, so I'm actually going to move my y over to this side so it matches my matrix better. All right, so we'll go this way. Negative 1, when I have negative 1, well, negative 1 squared is what? That's 1. Okay, so that would be 1a plus negative 1 times b plus 1 times c equals 5. Does everyone see how I did that? So I'm taking this coordinate right here. X squared is 1. X is negative 1. And then the coefficient of c is 1. And then that equals y, which is 5. How many are with me? Okay. So another equation. So that's my first. I need 3 of them. Another equation if I use this one. Well, what's x squared? 0. What's x? 0. Plus 1c equals 8, right? So x squared is 0, x is 0, and c is always 1 in that row, and then that's equal to 8. Okay, I want you to come up with your last equation, the last row here. Jaden, hold on to that thought that you just said. It's a good point. Okay, so if I use this point, what's x squared?
1.
What's x?
1.
What's this?
1.
What's this? 13. Everyone with me?
Yes.
Now, once I have my equation, or my 3 equations, I can actually use what? Yeah, reduced row echelon form.
Yes.
So let's enter that matrix in, the 3 by 4, and then use reduced row echelon form to get what A, B, and C are. Hopefully, you end up with an identity matrix as part of your augmented matrix there. And over here should be your A, B's, and C's. Yes? Right here? I took 3 points. In those 3 points, I said x squared, x, and then 1. C is always, I'm using the coefficients of these. So the coefficient of A is x squared, so I took that and squared it and put it there. The coefficient of B is x, so I took that, negative 1, and put it there. Coefficient of C is always 1. And then that equals y, which in this case is 5. Okay, so same thing here. I took 0 and squared it to get 0. Took 0 as x. Coefficient of C is always 1. And that equals y, which is 8. Okay? All right, does everyone have the matrix in?
Yes.
Okay, so you've got your matrix. So second matrix, oops. We got our matrix. I've already entered mine, but go to edit. You got your 3 by 4. Put it all in. And then you go to matrix and calculate. or excuse me, matrix and math and go down to reduced row echelon form. Just letter B and select matrix A. And we get that. 148? Now, tell your neighbor how you know that the 1 represents A, the 4 represents B, and the 8 represents C. Okay, how do I know the first one's A? Lee?
Because it's basically saying 1A plus 0B plus 0C equals 1. So A, if B and C are 0, then A has to be 1.
Good, that's 0 and 0. And we know that this is A because A is the coefficient of our x squared, which was our first value in. Very good. So this is, if we rewrite it, we get y equals 1 x squared plus 4x plus 8. Now, we don't need the 1 there. We can get rid of that and just write it as x squared. Now, Jaden pointed out a minute ago, when we were doing this one, I heard him say, well, yeah, this right here, since the x is 0, when x is 0, that's your y-intercept, which is, that's your c term always. So we could have known our c term right away by seeing that. Seeing it? Get it? Okay. There we go. Up to you which method you use. Okay? I don't have buy-in either way. That's up to you. Your assignment today is 1 through 12 all, 13 through 25 odds on the example side. So example side, 1 through 12 all, 13 through 25 odds. 1 through 12 all, 13 through 25 odds.
Crap, 25 is not.
Okay. Guys, Jaden a minute ago asked how if you have a list, how do you get the lines, like the lines to actually show up on your stat plot? So for those of you that want to hear that, you can listen. If you don't want to hear it, you don't have to listen. It's going to be on video, so you can watch it later if you want. But if you wanted to do that and you still you have this in your stat, make sure your y equals empty still. And what you're going to do is you've already calculated your quadratic regression. So since you've calculated quadratic regression, you go to y equals. And under this y equals, you're going to push vars. So VARS. And then you're going to go down to statistics, option 5. And then you want a statistics equation, which is EQ, so you got to arrow to the right twice. And you want that regression equation. It's going to take the very last regression equation you used. So the last one I used was the quadratic, not the linear. So there it is. That should have popped into your y equals menu there. You could have just typed it in also, but sometimes they get really kind of big. And then you go to graph, and it should show up.
I just realized I used the plus as my symbols, and it's not a line.
Oh, really?
Yeah.
Oh,
It's kind of off.
I'll have to check that out. What's up?
So when I go to the bars and I do the regular equation, right? It keeps.
Very good question just came up on number 7. So if you take a look at number 7, I'm sure others will have that same question. First thing is, this is 3 times that quantity x plus 2 times that quantity x minus 2. The question was, do you multiply the 3 in first, or do you just multiply these two first? Personally, I multiply the quadratic, or the two binomials first, x plus 2 times x minus 2. And for those of you who remember difference of two squares from this summer, or from algebra, that should be a quick multiplication. You should be able to do in your head. If you don't, then you're going to have to FOIL it out or whatever you do. But once you get that, and you get 3 times x squared minus 4, which is what that multiplies out to.
Yeah.
Okay?
3x squared.
When you get that, then you multiply this in. Now, if you choose to bring the 3 in first, you only bring it into one of the binomials. You don't bring it into both of them. Okay, otherwise you're multiplying it by 9. Bring it into one of them. Yeah?
I have a question, like on number
Think,
2,
man.
when
Yeah.
you do if you do 3x times x, would that be 3x squared?
Yeah, 3x times x is 3x squared. Yep. Any other questions on those top ones that you can see? Good questions.